When you are asked to find the domain of rational functions, what will you do? Let us first recall the definition of rational function. A rational function is of the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions and q of x is not the zero function. Q of x or the ones in the denominator should not be equal to 0 because it can make the function undefined. So the domain of the rational function f of x equals p of x over q of x is all the values of x that will not make the q of x equal to 0. In other words, values of x that can make the denominator 0 are not included in the domain. To find the domain of a rational function, first equate the denominator to 0. Next, solve for x. For example, if we have x minus 1 equals 0, x equals 1. Let's have some examples. Give the domain of the following rational functions. As you can see, we have 4 functions. Let's start with a. F of x equals 1 over x. So for the solution, we equate x with 0. Thus, the domain of f of x is a set of x's where x is an element of real numbers such that x is not equal to 0. All numbers except 0 can be replaced in the function, and it corresponds to a unique element in the range. Let's try to illustrate. The value of the function at 1 is 1. When we evaluate the function at -2, the value is -1/2. If we try to replace the x with 10, the value of the function at 10 is 1/10. However, when we try to evaluate the function at 0, the function becomes undefined. 0 should not be included in the domain. Let's have our second example. F of x equals 3 over x plus 2. So first, we need to equate the denominator with 0. So, x equals -2. The domain of f of x is a set of all x's where x is an element of real numbers such that x is not equal to -2. So again, let's try to illustrate. When we evaluate the function at 1, the value of the function at 1 is also 1. Evaluating the function at 0 will have a result of 3/2. However, when we try to evaluate the function at -2, the function is undefined. -2 is not part of the domain. Let's have exercise C. So f of x equals 2x minus 5 over 3x minus 7. To find the domain, we equate the denominator with 0. So 3x minus 7 equals 0. Now, 3x equals 7. Dividing both sides of the equation by 3, x equals 7 over 3. So the domain of f of x is a set of x's where x is an element of real numbers such that x is not equal to 7 over 3. Let's have our last example. F of x equals 4x squared plus 4x plus 1 over quantity x squared plus 3x plus 2. At one glance, you may think that finding the domain of the function is difficult, but it is just easy. We try to factor first the expressions in the numerator and in the denominator. So 4x squared plus 4x plus 1 is just equal to quantity 2x plus 1 times quantity 2x plus 1, while x squared plus 3x plus 2 can be factored to quantity x plus 2 times quantity x plus 1. Now, we have two values of x's. So we need to equate first x plus 2 to 0. X equals -2. Then we also have x plus 1. Equating it to 0, we have x equals -1. Therefore, the domain of f of x is a set of x's where x is an element of real numbers such that x is not equal to -2 and x is not equal to -1. These two values can make the function undefined. They are not part of the domain.